Hi, my name is Ted Perkins, and I help to oversee the floodplain mapping that is done for our region that includes Washington, Idaho, Oregon, and Alaska. FEMA floodplain mapping is developed as a tool to guide communities to build in a way that greatly reduces risk to buildings, and it helps to better define the appropriate flood insurance rates for your community. The floodplain mapping accounts for risks associated with a 1% annual chance flood event, often termed a 100-year floodplain. Ketchikan Gateway Borough was chosen to be updated because FEMA has been updating the coastal flood maps across the nation due to better technologies and computer power to model complicated coastal risks, and there is updated science on how these risks present themselves, particularly in the Pacific Northwest. Because Ketchikan Gateway Borough's maps have not been updated in quite some time, some of the data behind the maps needed to be improved as well. The new floodplain map is a digital product where one can pull in other layers to better locate oneself to these flood risks. It also includes using a more consistent zero ground elevation than what was used in the past due to improved technologies. Prior to reaching this preliminary map stage, we have been coordinating with the community staff for many years to ensure we are using the best available data. To determine the 1% chance flood event for coastal areas, one first determines the still water inundation due to tide and storm surge at a broader scale. It also captures localized instantaneous wave run-up and overtopping that captures high velocity hazards with the potential to cause significant damage to the community. FEMA defines these high hazard velocity areas as VE zones, differentiating from AE zones that are only subject to still water inundation or relatively weak wave actions. Historical records of water levels in Tongass Passage were used to derive the 1% annual chance still water. A two-dimensional wave model was developed, which was used to hindcast more than 100 historical storms. The run-up and overtopping hazards from those storms were analyzed at the nearshore transect across the shoreline of Ketchikan Gateway Borough. This information was used to depict the floodplain mapping. FEMA received comments from the community on the preliminary flood study issued in 2017 regarding the precision of the topography we had available, which, with closer scrutiny, allowed for us to better identify parts of the shoreline and better represent the tidal effects. Additional transects were also added in the engineering analysis to better capture the nearshore run-up and overtopping hazards, where overtopping hazards due to the presence of exposed bulkheads along the steep shoreline are not captured by the transects due to its spatial resolution, and additional analysis was also performed to better define its flood risk that reduced some of those areas from the VE zone to AE zone designation with reduced space flood elevations. This revised preliminary floodplain mapping reflects those changes. As we pulled this into the entire countywide flood study, we also updated some riverine flood risk information. New hydrologic and hydraulics analysis was also performed for Ketchikan Creek, Hoadley Creek, and Shanbar Creek. Hydrology is determining how much water gets into a stream before we model the hydraulics, which takes these flows and routes them downstream to see how deep and how wide the floodplain gets. The hydrology for Shanbar and Hoadley Creeks was determined by extrapolating from nearby riverine stream gauges by USGS to determine the 1% chance flows. These equations predict the peak flow rates based on characteristics of a stream's watershed, such as drainage area, and are called regression equations. The hydrology for Ketchikan Creek utilized a combination of flows computed using a watershed model for Ketchikan Lake Dam and the USGS regression approach. The hydraulic analysis was performed using HEC-RAS software, which models the physics of how the water moves down the channel. The stream geometry within the HEC-RAS models was based on detailed topography that comes from LiDAR. for the overbanks, and then field survey was performed for the channel road crossings. If you need more information to understand how this flood risk was determined, please contact us at the email below with information on the location you are interested in and some background on what you'd like to understand better, and one of our experts will contact you to talk in further depth. It is likely easiest if you provide your email and/or phone number and an address in the area you are asking about. Thank you very much for your interest in our maps.